Hyperbolas are the ones that go up and down, or left and right. Well, what happens is that within them, we drew these rectangular boxes. You know, all these distances again. There's a focus. There was a minor axis, a major axis, the co-vertices, all that stuff. All of these things are still there. I always labeled it a little bit differently than what the book said. Remember how we said the ellipses had a vertex and a co-vertex? The hyperbola technically only has a vertex. It doesn't have, that's called a co-vertex. I called this point here the co-vertex, just so we knew which direction things were going. It's not technically called that, it's called something else, and I don't remember what. But we do the same setups. You have stretched up and down, stretched left and right, hyperbolas. We're going to have them shifted through. There's still going to be an a squared, a b squared, there's going to be a c squared. The difference between hyperbola versus an ellipse is that the equations are as follows. So you have your ellipse, or excuse me, your hyperbola equations. X minus h quantity squared over a squared. Y minus k quantity squared over b squared is 1. This means it's stretched left and right. Okay, it's left and right. Because the x squared comes first. When the y squared comes first, it's up and down. Notice that the a squared, b squared doesn't have any difference. It's just where they're placed. Okay, that's the only difference. Whereas in ellipse, the a squared was the bigger of the two values, and then it went back and forth. Here, it's just what comes first, the x or the y, and that's how you know what direction it's moving. The h and k again is your center. A is always going to be the distance from center to vertex. This B value is always the center to what we call that co-vertex, even though it's not called that in hyperbola. C is the center to your focus. And obviously your focus is going to be further out than your vertex is, because the vertex always looks at a focus. So in a hyperbola, to figure out that value of c, since this is a subtraction symbol, it's going to be a squared plus b squared to get your c squared value. That's the difference. B is always going to be the center to what we call co-vertex. It's a point, and you'll see it's how we're going to create. When you guys did this last year, did you guys create that rectangular box to get your asymptotes? The B value tells you how far out to go with that box, because the vertex will be placed where the parietal is going to touch on both sides. That B value tells you how stretched out that box becomes. That's all. It's not technically called that. I think it's called the, is it the transverse? No. What's it called? The transverse axis is what the vertex in the center lies on. The non-transverse axis, I guess? I don't know what it's called. Conjugate axis. It's called the conjugate axis. They call it the conjugate axis. I call it the co-vertex, okay? And we'll show how it goes. I don't think that term comes up very often, though. To be honest with you, let's just do a problem and walk through. We'll go right with the complete square thing and go through and list everything out in the graph. It's the easiest way to do this. Find the standard form of the equation with foci at -1 and 2, 5 and 2, and vertices at 0, 2, and 4, 2. So we have foci at -1 and 2, and 5 and 2. -1 and 2, 5 and 2. There's my foci. Vertices at 0 and 2, and 4 and 2. What direction is this opening? Left and right. Vertices always open to the focus. Right? G, what do you think occurs at the midpoint of either the focus or the midpoint of the vertex?
The center.
You're right, it's
Thank
the
you.
center. So, what's 0 plus 4?
0 plus 4 is 4.
4. What's half of 4? So our center is located at 2, 2. Our HK is at 2, 2. I know it's going to be a left-right one. So if it's a left-right one, is it going to be a what's going to come first, the x squared term or the y squared term? The x squared term. I know that's what the equation is going to look like. Just for that right away. Now I just count. Knowing that my center is at 2, 2, how far is it from 2, 2 to 4, 2? So what's your A value?
No,
2.
Oh, you don't have to square it?
Not yet. I'm just finding A. I know that my A value is 2, which means A squared is 4. I don't know what my B value is, but I do know what my C value is. What's my C value? 3. And I know that A squared plus B squared is C squared. So 4 plus what is 9? 5. So that means my B squared is 5. So I have an equation. That's for B, just to find B. I'm just writing the standard form of the equation. If I wanted to label up those other points, then I would, you know how you would add and subtract the square root of 5 to your y value here. The 3, I just counted. I went from 2, I went 1 little, 2 little, 3 little. So it's x minus 2 quantity squared over 4 minus y minus 2 quantity squared over 5 is 1. Write the form of the equation.
So you're just not
If it asks to just write the form of the equation, that's all I gotta do. I have another example that we'll go through, like when we're given it in terms of what is that, quadratic form, and then we'll figure out all the parts and label everything. Not so bad. I assume all of you had nice weekends. I'm sorry. All right, let's look at them. Asymptotes. There is a shorter way to write out and find your asymptotes by using the coefficients of the problem as you go through. Last year when you guys did that, we had to find the slope between the center and remember how we did that little endpoint on the B over A values and stuff? You did all that. It's kind of the same basic principle here, but to get the equation of the asymptotes for the hyperbola themselves as they go through here, all we have to do is one of the following. If the transverse axis is horizontal, which means it's an x squared first, it's going left and right. I shouldn't have drawn that with an ellipse around it. I should have done it like this. I am. Sometimes I think it's funny.
I thought it was like that.
So let me show you these two equations. Now I'll put them up on the board here. It's just a quicker way to write out the equations for those in slope-intercept form. So if we look back at the equation we just had, where it was, we had x minus 2 quantity squared over 4 minus y minus 2 quantity squared over 5 equals 1. And we knew that this was a left-right hyperbola. If I just wanted to write the equations of the asymptotes created by that, well, y is going to equal what's our k value in this problem? 2 plus or minus a over b. Well, excuse me, b over a. What was b? It's root 5 and a was 2. So it would be root 5 over 2 times x minus was it 2. And that's how you would get your equation of the slopes. Now, to graph root 5 over 2, I got to go up root 5 over 2. Yeah, that's going to be a little bit nasty looking, but if it's just write the equation, there's your equations. We know that you can draw the dotted lines through that to get some funky fraction if you had to make it work. It's not that big of a deal. It's just another quick way to write it out. Whereas before, we would have to go through and draw out that box, get the center point, we had the vertex here. We knew what this was because we went up and over your A or B or whichever one you were going. And then you would find the slope between those two. Then
Wait,
you,
are we doing
we could do it. This is the long way of doing it. This is just right from the formula. It's just the longer way of doing it. So let's just take a generic form, your quadratic form where you have to do all the completing the square, and let's just find all of it. Centers, vertices, co-vertices, equations of asymptotes, and graph it all. This is just a longer algebra problem. So let's just do the whole spiel. We have 4x squared minus 3y squared plus 8x plus 16 is 0. Now let's do the whole shebang. A bunch of completing the square here, so what are you going to do first? What are you going to move? Move to 16 and just regroup everything. I got that. What do I have to worry about with the completing the square part on the 4x squared?
There's a 4.
There's a 4. So what do I do? Take it out. I don't have to worry about anything with the 3y squared because there's no y term. I don't need to worry about it at all. I took out a 4. I got to put a 4 back in times something. So, what's half of 2? 1. What's 1 squared? 1. Now what do you do? Divide by the negative 12. Oh, looky looky. This makes the first term now negative. It makes the second term positive. Which means it's not an x squared left right one, it is a y squared, because you rewrite it since subtraction is second. Does that make sense? It's a very, very common twist they will put at you.
Wait, so
Yeah, rewrite it. Now, since the y squared is
why
positive,
not plus there in this place?
what's negative divided by negative 4?
No, but why?
Remember, originally it was negative 3y. Here it was negative 12, so it's when we divide it out, change the signs. So that's how it flips the order. So it's a y squared hyperbola, which means it's an up and down line.
So originally what is negative, like minus 3y
Yeah.
plus
Yeah, because you had negative 3 divided by negative 12, which gives you positive 1/4. That's why it switched the signs. So where's your h and k?
negative 1 and
Yep. There's my HK. HK. A squared is 4. B squared is 3. When what? Which means my 7 squared is my C. No. What's C squared gonna equal? 7. So you have an A value plus or minus 2, a B value plus or minus root 3, a C value plus or minus root 7. Divided by the negative. It's a common thing, you'll see this a lot, and that's why they switch the order. And then we have our asymptotes. It's a vertical one, so we just have to fill in the blanks for that. K value is 0, so it's just going to be y equals plus or minus 2 over root 3. Which, yeah, what would it be then? 2 root 3 over 3. 2 root 3 over 3. So it becomes 2 root 3 over 3 times x plus 1. And those are your asymptotes then. So, the sketch. Now we can this up. Center was at, was it 0 and 1? Or negative 1 and 0, excuse me. Our A value is the distance.
No, negative.
Oh, did I put it at 0, negative 1, excuse me. Or did I? I know it's going to be stretched vertically. So now the distance from my vertex to the center was the A value. A in this case was what, plus or minus 2, I think? So I just have to go up and down 2. So vertices at -1, 2, -1, -2. Covertice, that's moving left and right. The covertice moving left and right was the square root of 5, I believe, right? 3, excuse me. So the square root of 3. Square root of 3 is a little bit more than 1.7-ish, because it's going to be less than the square root of 4. So it's like 1/7. So instead of being here's 1, so maybe about here. Just guesstimating. To what value am I adding? To what value am I subtracting the square root of 3 in the ordered pairs? Yeah. So my ordered pair is going to be -1 plus root 3, comma 0, -1 minus root 3, comma 0. And then last year, you guys did this. A lot of the ordered pairs you guys were using last year gave you clean spots on that upper corner, so you can find the slopes rather easily. As you can tell right now with this equation, the slopes of 2 root 3 over 3, that's just awful. It's really nasty. But you get the idea that you can just draw the asymptote in now, like this, and like that, because you labeled what the asymptote is. The only other thing we have left to plot on the graph and label is going to be the focus. To what value then am I adding the C values? Is it going to be adding to the H or to the K in this case? We're going to add it up and down, so we're adding to the vertical, the K value. So the focus will be at -1. My K value was 0 to start with, but our C value was root 7. So we have positive root 7, and -1 comma negative root 7. Square root of 7 is greater than the square root of 4, but less than the square root of 9, so 2.5-ish, I don't know. We'll call it about here, and here. We're just guesstimating. We labeled the exact, we guesstimate in our graph. And then you remember how to graph these? Hug your asymptote, go through the vertex, and hug the other asymptote. And that's all you do. It's a lot of steps. And the goofy part really is the fact that they're just going to give you a lot more radicals and stuff in pre-comp than what you guys saw last year. Yes, sir?
I don't understand why you found the vertices and
The vertices and covertices go with the A's, B's, and C values. So always, in any one of the conics we deal with for the ellipse or the hyperbola, the A value is always the distance from your center to your vertex. The B is the center to the covertex. Here it's just not called a covertex. It's just those outer points for where the parabola doesn't go, direction doesn't go to. The C values always need a distance from center to focus. So once we figure out what the A, B, and C values are from A squared plus B squared, get the C squared. Because it's always the opposite sign to do that. We're just adding either vertically or horizontally to our H and K's. Once we figured out that this was going to be a vertical one, I knew my focus and my vertex and my center all are going to have to share the same vertical line.
Okay, how do you know if it's vertical?
What comes first, y squared or x squared?
So if it's y squared,
Yeah, that's the trick. That's the trick between these two equations. X squared comes first, it's left and right. Y squared comes first, it's up and down. In this one, it originally had an x squared first, but then the sign is changed, so it flip-flopped when you put them in descending order. That's really the only screwball in this here. Oh, gee. I think I had another one at least. Let's see if we can do it this one. let's see if we can use the asymptotes to figure out the equation of the whole thing. See if we can do this. So we have vertices at 3, -5, and 3 and 1, and asymptotes at 2x minus 8, -2x plus 4. Can we figure out the standard form of the equation? This is totally different than what you did last year. Last year you were given vertices and a foci, work yourselves through it. Or you had a co-vertice and a vertex, and you go through it that way as well. This time we're going to use the asymptotes and see what we can come up with. Again, the easiest thing to start with is just a rough sketch graph. That way you can tell what direction is it moving, left and right, or up and down. So if we're at 3, -5, for one of them, and the other one is at 3 and 1, if those are my vertices, which way is this going? It's going up and down, which means it's an x squared or a y squared hyperbola. Y squared. As soon as you notice that, start filling in the blanks. Write down that you know it's got to be this. It has to be a y squared first. It has to fill in with those. You have asymptotes. Write down what you know. Catch on what? Yeah, absolutely. And you start with the stuff that you can figure out easily. I can easily find the center here. What is -5 plus 1? What's half of that? -2. Which means I have a center, I have an HK at 3, -2. So I can start filling in the blanks. So I'm going to have a y plus 2 quantity squared, x minus 3 quantity squared. I also know what my a value is. My a value is 3, right? So my a value is 3. So a squared is 9. So I know that much. So now I look at what we have as far as the asymptotes. If we know that we have asymptotes, y equals 2x minus 8 and y equals -2x plus 4, we can start playing around with some numbers so you can figure it out. So we know that the two, let's see here, let me move this down a little bit. We know that the 2x if you distribute itself through, or I don't even put the x in here, the 2 has to equal the a over b, doesn't it? In that formula? Which one of those do I know? A. So I know that 2 has to equal 9 over b. What's that? Oh, 3, thank you. Sorry, I got so used to writing that. So when you have fraction equal fraction, or you have just the unknown in the denominator and the known on the outside, remember, exchange it on the diagonal. Yeah, so what's your b value here? 3/2. So my b value is 3 over 2. Yeah, absolutely. We had that a lot last year. We had a lot of fractional b values. So our b value is 3 over 2. Oops. So what's b squared then? 9 over 4. If you just had the right equation standard form, isn't that all you have to do? Do I have to find everything else? Okay. No, it doesn't say that you have to plot. What I do with the plot stuff is I'm doing this, I do the original plot stuff, that way I can visualize what direction is it going, so I know which of the two sets of formulas I'm gonna use. Am I gonna use horizontal formulas or am I gonna use vertical formulas? That's the only reason why I plot these, because then I can start to visualize it, I can count better than I can do math, sometimes. Let's see what we can do with these before we get too crazy here. Try that. This starts on 760. Sorry, I forgot to write that down.